Okay, so let's move on to simulation modeling and what if scenarios. So the first question I've got is, how does simulation help engineers test the what if scenarios without needing to build physical prototypes?
As we've discussed previously, there's a lot more data available in the world. And with that, you can analyze that data and you can make good decisions based on that data. However, you still have to actually apply the decision and the possible solutions that you've generated from that data. And with that in mind, as you touched upon, you can build physical prototypes and you can try things. However, it's really important to be able to not limit yourself to what you can try and what you can physically build. And therefore, running simulations and what if scenarios really is beneficial to the industry to allow you to really hone in on what is the right solution and to not leave yourself with any incorrect influences making your decision as to what the best approach to take is. And simulation tools really are used to be able to to be able to load those tools with the amount of data we have available really does help you get really into, by the time you get to physical testing, you are testing a very mature solution effectively.
So again, physics machine learning is involved here, isn't it? Can you
Absolutely.
explain how using that improves simulation tools like CFD and FEA to speed up that decision-making process?
So yes, the use of physics machine learning does allow you to really hone in on the solution with a much more mature model by the time you get to running different simulation and different FEA loops and so on. It is important to understand the processing power that these things take, because FEA, often a very high resolution mature model, can take many hours to run and operate. Whilst it's much, much quicker than obviously building physical prototypes and going to test houses and testing them, when you start running numbers and you realize that you're potentially wanting to run 20 simulation runs, that can take a number of days to actually complete. And therefore, the more concise and the more, if you imagine a pyramid, the more you can start near the top of that pyramid, the quicker it allows you to get to the top of that pyramid and the point and the actual optimized solution effectively.
Is there a cost benefit in doing this? There must be
Absolutely.
if it's against a physical asset.
Yes. So, I mean, the cost benefit relates to the time of being able to get the answer, which is effectively elapsed time, but also even the processing power that we've been discussing energy and energy usage and efficiency. Having a lot of computers running at very high, processors running flat out and fans blowing and so forth, that does actually add up to create quite a lot of energy consumption. And these are areas that you do want to improve upon.
So what are the other benefits? When we go from like a simulation model to the real prototype, what are the benefits of linking those models with the real hardware or test rigs in real time?
The real key is the fact that you can take once you iterate towards your ideal model effectively and your ideal solution, and then you run that and test that, the data you take from that can be then fed back into the model to give you a more mature and a better correlated model, allowing you to produce much better resolution for that same activity next time, but also for maybe an adjacent activity. So the next piece of work you do, which is 50% similar, you are able to work with a more mature, that 50% that you're taking from the previous experience is more mature and validated and correlated against real practical application.